Okay, hi and welcome to some notes on exploring parabolas and more importantly, their features. Really all in the guys that we're going to be graphing. That's the goal for most of this entire unit actually, is to identify features and how we get them from the various forms we got. And here is standard form, just one of the ones that I'm putting up there to start with. And then finding features so that we can graph all the important points. We're really going to tie everything in we've done with parabolas, polynomials, quadratics, all of that gets tied together here in one kind of culminating event almost in graphing. So what we're going to do today is we're going to quickly go over some of the basic terms, some stuff you'll be familiar with, maybe some stuff that's new. We're going to graph one by making an evaluation table and identify all the features and maybe play with the forms. All right, so let's get started. We should be pretty familiar with the fact that all of these parabolas are going to be what we say is U-shaped graph, meaning that they're going to open up or down in some fashion, and they should look like a U, however that is. Now we're going to translate them all over and move them, but they should always retain that U-shaped value to them. One of the important things that we like to do is denote which way they open, that U shape, and we use the A value for that to decide. If it's a positive A value, it's going to open upwards, like I'm drawing over here. And if it's a negative A value, it's going to open down. That is a form of translation. We're flipping it, but we'll talk more about that later. But really, we just look at the A value. In any form, really, it works in any form that there is. Another thing that we like to do with parabolas is look at that symmetry. Now, with the symmetry of a parabola, I'm going to switch colors here, purple. I'm trying to keep a color scheme for you. The axis of symmetry, or the line that the parabola has that retains its symmetry, meaning that if you fold over it, that it would be exactly the same distance away, whatever points on one side to the other. So meaning this point here is located 1, 2 units on this graph away from this axis of symmetry, and you'll notice that if I go on the same exact y value, and this happens to be the x-axis, but if I go with that same exact y value, that same units away, 1, 2, there should be a point, and that's true anywhere you go. I'm using these nice grid points, but wherever I go and find a nice point, you'll notice that there is whatever the units away, and so in this case 1, 2, 3, that exact same distance away to the other side is a point at that level of y, whatever the y coordinate is there. So symmetry is super nice for graphing parabolas, because if you graph one of these, you get another one for free. All right. So there's symmetry. Turning points, or as we've seen before, or also known more commonly as the vertex, is the point at which the parabola turns, meaning changing from increasing to decreasing, which we'll talk about in a second. It is what it sounds like, the point of convergence, if you will, the center, the location that we're going to translate. We talk a lot about this vertex and how it moves around, and it takes the parabola with it, if you will. So that's the vertex. We can label these minimums or maximums. A minimum then would be the lowest point on the graph. So for example, this one here that I'm denoting, that would be the lowest point of this parabola, again considering y values. This would be the maximum point on this parabola, meaning that there's no point higher for this one, and this vertex is the lowest point, so minimum or maximum. And those are absolute, if you were wondering. Again, we mentioned increasing. We've done this before. An increasing function is a segment of the function that from left to right is increasing, right? And again, from left to right. So that segment there in blue, if you go from left to right, if you travel along here like this, from left to right in x values, that is going up in y values, so or increasing. And then vice versa, a section of the function that is decreasing would be going from left to right, again considering x values, so moving along the x-axis, that the y values would be decreasing or going down. Okay, so that would be the increasing and decreasing portions of those. Don't forget here that we're going to mention that this does need to be in some form. Usually we start with standard form, which I've denoted up here for you, which the leading degree for all of these in that form would be a 2. Actually, you shouldn't see in any of the forms more than a degree of 2 for any x value or variable that's involved. That makes it a quadratic specifically. Okay. Solutions, we spent a giant unit on solutions. Solutions are super useful now. We've been solving and we didn't really know why. Well, now we will know why. It's going to locate 2 of these points that are super useful for us in graphing and identifying features and parts of this parabola. So solutions and solving is a big portion of our game. End behavior is something that we've seen. It's been a while since we've talked about it, but the basic part of end behavior is what's happening at the ends of the graph, quite literally the end behavior. And I'm going to highlight this end behavior so it stands out in these giant red arrows, and you'll notice what's happening is that these are both going down. Uniquely for all parabolas is that they will always go in the same direction, so both down or both up. So, and we're going to get into the fancy writing of that end behavior when we get to the example. We'll bring it up then. And then, of course, we'll hit domain and range. Remember, domain then is what's happening with this function from left to right. Where can I find it? And then that would be your domain. And then remember, range then is where can I find this function vertically? Where does it start? Where does it stop? Along the y-axis. So I know, doesn't that look like a lot? It totally does. But most of these things we've talked about before. You've seen them, you've worked with them, you've solved them. So there isn't much new in that category, except for we're going to package it all together and see what it looks like. All right, I think it's time for an example.